Have you ever stopped to think what actually makes your phone smart? Or what's going on inside your computer that makes it, well, compute? It really all comes down to a few basic parts, these tiny invisible heroes of our digital age. So today, we're going to pull back the curtain on the tiny switches that run pretty much everything, semiconductors.
All right, to get us started, let me just throw a question at you. What in the world could a simple little LED light have in common with a giant room-sized supercomputer? I mean, they seem like they're from different planets, right? But believe it or not, they share the exact same secret ingredient. And that secret ingredient? It's semiconductor devices. That's the answer. These are the fundamental building blocks, usually made from plain old silicon, that are designed to control the flow of electricity with incredible precision. Think of them as the microscopic brains and highways inside every single gadget we use.
Okay, so where do we even begin with all this? Well, we start at the beginning, with the simplest, most fundamental component of them all, the diode. The easiest way to think about this is as the one-way street of the electronics world.
You see, a diode has one very, very simple job. It lets electrical current flow through it in one direction, and that's it. If the current tries to go the other way, nope, it gets blocked. It's the ultimate bouncer at the door for electrical flow.
The absolute best way to picture this is like a one-way gate or a turnstile at a stadium, right? You can walk through it one way, no problem. But if you try to turn around and go back, the gate just locks up and blocks your path. Super simple and super effective.
Now, in electronics, we have some technical terms for this. We call it forward bias and reverse bias. When electricity is flowing in the right direction, that's forward bias. The gate is wide open. When it tries to flow backward, that's reverse bias, and the gate slams shut.
And this simple one-way trick is absolutely crucial in the real world. Diodes are what turn the AC power from your wall outlet into the DC power your phone can actually use. They protect your gadgets if you accidentally plug in the power cord backward. And yep, every single LED light is actually a special kind of diode that just happens to glow.
All right, so we've got the one-way street. Let's move on to the next component and see how things get even more interesting. If a diode is a simple gate, then the transistor is like a sophisticated control valve. This is where electronics get really, really powerful.
We're going to start with what's called a BJT, or bipolar junction transistor. And this thing basically has two superpowers. First, it can take a tiny little electrical signal and amplify it, making it way stronger. And second, and this is maybe the most important part for our digital world, it can act as a super fast electronic switch.
The perfect analogy here, seriously, is a simple water tap. Think about it. With just a tiny, easy turn of the handle, that's your small control signal. You can control a huge, powerful flow of water coming out of the faucet. A transistor does the exact same thing, just with electricity instead of water.
So how does it actually pull this off? Well, you apply a tiny little bit of current to its middle connection, which is called the base. That tiny current is like your hand turning the tap. It opens a valve and allows a much, much bigger current to rush through the other two connections. If you turn off that little base current, the big current stops. It's a switch that you can flip on and off using electricity itself. Okay, now that brings us to the modern champion, the undisputed king of transistors in today's world, the MOSFET. This is the device that really truly changed everything and made the technology we have today possible. MOSFET stands for a very long name, but what it does is what matters. It's an even better, way more efficient type of transistor. It is, and this is wild, the single most manufactured device in all of human history. It's the heart and soul of every CPU, every memory chip, every smartphone on the planet. So remember how the BJT was like a top handle you had to push with a little flow of current? Well, a MOSFET is more like a touch-sensitive button. You don't have to push, you just apply a voltage, basically an electric field, to its gate. And here's the magic trick. It takes almost zero power to keep that switch held on or off. And that little difference is the key to, well, everything.
And that incredible efficiency is exactly why MOSFETs took over the world. They use almost no power. They can switch on and off unbelievably fast, and most importantly, they can be shrunk down to almost atomic sizes. This ability to get smaller and smaller is what drove Moore's law, allowing us to pack billions, literally billions, of them onto a single tiny chip. That's what powered the entire digital revolution.
Okay, so we've looked at the one-way gate, the amplifier, and the super efficient smart switch. Let's kind of zoom out now and see how these simple ideas, all of which start with silicon, which is really just purified sand, build up to create the supercomputers we have today.
Let this number just sink in for a second. Billions.
A single processor chip in the laptop or phone you're using right now has billions of those tiny MOSFET switches, all flipping on and off thousands of times a second to do all the work. It's a scale of engineering that's just hard to even imagine.
So, let's do a quick recap just to lock all this in. The diode? That's your simple one-way street for current. The classic BJT transistor is fantastic for amplifying signals and for basic switching. But the MOSFET? That is the undisputed champion for fast, efficient, low-power switching. It's the engine of all things digital.
And you could literally find them everywhere. Pop up in your phone charger, and it's going to be full of diodes. A really good stereo amplifier is probably using BJT transistors to make the music loud and clear. And the brains of any modern computer, the CPU and GPU, that is 100% MOSFET territory.
So ultimately, you can boil this entire explainer down to one core idea. These devices, diodes, BJTs, and MOSFETs, are what give us the power to control and process electricity. And that control is what makes every single piece of modern technology work. For more than half a century, our ability to just shrink these switches and cram more of them onto a chip has completely transformed our world in ways we couldn't have predicted. Which leaves us with a really exciting final question. What will the next tiny switch look like? And how is it going to change our world all over again?